how to calculate the cost of a clay workflow and what does it even mean that an LLM or AI model is cheap. I want to explain that. So the way I'm going to explain it is a actual workflow that I've built, but I've adapted it a little bit to show this off, this pricing thing with workflows. This is not about why this workflow looks like that. Let's just say for any given use case, there's a workflow, it has a few columns, those columns have certain costs, and how to calculate that. So there is two ways to pay for work in clay. That's clay credits, which you can purchase in different volumes and different prices with your clay plan, and you can use your own API keys, so you don't have to use clay credits, but you can do the work in clay, but actually you pay the cost directly with the API provider. This is what that means. I mostly work with my own API keys. For the sake of argument here, I did a few things with clay credits too, but mostly I want to show how the cost is calculated in the most efficient way, which is usually using your own API keys. So first things first. For this question, does a company have a free plan, yes or no? When you start with an expensive model, let's say GPT-4o, you get really good results. So let's look at this. This is the true result, and this is what GPT-4o said. That's actually a 100% match rate. I would say that's probably not going to be 100% across 10,000, but it's a really, really, really good result. So we can run with that. What does it mean that it's expensive? Let's say it's not exactly that, but let's say this is column 4. Let's say column 4 has a price of 3.9 cents. And what I need to do if a client asks me what will this workflow cost for 10,000 rows, then I need to know before I run it the average what a row will cost. So in this case, it's 3.9 cents, and let me actually, I just unhid those columns. So this is the cost for this row, this is the cost for this row, this is the cost for this row. So you can see it's all different. Same ballpark, but different. So I'm going to take those values, I'm going to paste them into a Google Sheet. And here I see the average of column number 4. I think that's even the right value there, but let's see. Okay, that was the right value. So what we've done here, and I think this already gives a long way of knowing how to calculate this. So we are only looking at column 4 for one row, which is this number. This column would cost, about 4 cents, $0.038. If we only use this column and run it for 1,000 rows, that would be $38. And if we run this for 10,000 by extension, it would be almost $400. And here comes in GPT 4.40 is a relatively expensive model, as you can see here. What is part of my work is to find cheaper ways to do this. So I want to get the same result. I want to get to a very good yes or no, or very accurate yes or no, but I want to do it much cheaper. So what I'm actually doing is to run the same prompt, but with a much cheaper model. In this case, it's a Haiku. And in this case, in this column, it's GPT 3.5. And I'm running the exact same prompt. And what you can see here, that they are wrong quite a few times. Again, this is the true result. And this is what the cheaper models say. Same prompt, just running it. So in this case, they are right. Here we have a difference. Haiku says, yes, they do have a free plan. GPT 3.5 says, no, they don't have a free plan. The true result is yes. So what do we do here? What my approach is to run two really cheap models. And if they are not in agreement, only then I bump it up to a more expensive model. And I have mapped out those prices the same way I did it with the other. And this is how that calculation looks. So column 1 has per row a price of like 0.2 cents. Column 2, about the same, similar price. Column 3, which is the column I'm only using if 1 and 2 are not in agreement, that is already much more expensive. That is not fractions of a cent, but actually 4 cent 50. And when you calculate that up, when you look at, let's look at 10,000 rows in this case. When I run 10,000 rows with these two models and see what result they get, I get to, where is it? There it is. I get to about $50. And what I need to calculate in column 3, since it doesn't run for every row, I would say the way it looks here, it runs for about 25% of the rows. So I would need to look at 25% of this price. I know this seems maybe a little bit complicated, but it's really all about what's the cost of one individual column on average across all of the rows we are using. And what you can see here, how much more expensive the higher end models like a Sonnet or an Opus or a GPT-4 or 4.0, they are just 10, 20 times more expensive. And when you calculate that up to 10,000 rows, it's a very different story than running these really cheap models. And I hope this is a little bit of a combination how to calculate model costs, but also how to circumvent and circumnavigate that. When you use your own APIs, for example, when you use clay credits for taking a screenshot, that's 2 clay credits. That may be anything between 20 cents and 0.2 cents and 15 cents. Actually, no, I confused that, but it's expensive. It's expensive. And when you use your own screenshot API, it's like a tenth or a 20th or a 30th of that price. It's much, much cheaper. And this is why when you know which API to use and which workflow logic to use, you can get same quality results, but in a much cheaper way. And I hope this explains it a little bit. Yeah.